All right. Going to start using Gnuplot this week. So the G on Gnuplot I pronounce. Some people call it Gnuplot. I don't care how you say it. Just don't tell me how to say it.
I think it's Gnuplot.
Gnuplot, that's perfectly fine.
It's like
So why are we going to learn Gnuplot? Here's the basic motivation. It's a program for creating plots of data. So if you've had to take a physics lab, which I think everybody in this room has or is taking a physics lab, sometimes you have to create plots of your data, and Excel is typically the thing that most people have experience using for creating simple plots of data. But Gnuplot is much more powerful than that. We're going to learn how to use this utility because it's going to be very common for us to need to plot data. So we want to be able to create graphs of data. It has a command line interface, which is actually very convenient, other than the fact that you have to type everything in, but that actually turns out to be very convenient as well, because that means it can be scripted. You can write Gnuplot scripts that will automatically be read by Gnuplot. You can recreate graphs very quickly if you write them as Gnuplot scripts instead of having to go in and click on different buttons to get all the configuration settings the way that you want them. And the reason, I mean, there are other plotting softwares out there, things like, Maple, Mathematica, they've all got plotting capabilities built into them. But what's really nice about Gnuplot is that it's simple and powerful. It is simple enough to quickly plot data. So just to get an idea of what your data looks like, it is very easy to get Gnuplot up and running and a plot on the screen. But it's also powerful enough to create publication quality graphs. Publication quality is a common feature that's touted for Gnuplot. You can create graphs that look nice without hardly any effort at all, that are good enough to put into a publication, something that you would write and get published in a journal. So it's very easy to get started, but there's all kinds of configuration options that allow you to fine tune or tweak exactly what your plot, what your graph looks like. It also has a really nice function fitting capability in it. And so if you need to do function fitting, so if you've got data that you know should fit some function, Gnuplot has a really nice function fitting in it. All right, so to get started, we need to install Gnuplot. So go ahead, open up a terminal, and you can check to see what Gnuplot packages are available by typing apt search Gnuplot. You're going to get a listing of all packages that match the name Gnuplot. The $ is my prompt. What is your prompt? You can look at it's on your screen, right? Okay. Sometimes it's a greater than sign. We want, so you want to do apt install Gnuplot 5 TAC X11. So note the 5. The one without 5 is Gnuplot 4. Gnuplot 5 is relatively new. It's got some sweet, sweet features, as Jack would say. Jack likes Gnuplot 5. If it's good enough for Jack, it's good enough for me. Apt is our package manager. Apt search Gnuplot. See if I've got this installed.
Oh, there's a Python Gnuplot.
There are lots. You guys not having troubles installing it?
I have unable to locate exactly which.
Man, Ruby really old.
You may have to run sudo in front of the install command.
I wrote apt, it just immediately brings the pseudo password first.
Yeah, you typed L.
So I looked up what Rusty Shackelford was.
Oh, did you?
Because I recognized it. It's
Hey, it's not letting me type my password.
it doesn't appear, but you're still typing.
Oh God, that's awful.
This is like the 5th thing I've downloaded today. I've been downloading stuff all morning.
So we want Gnuplot 5, and we want the X11 version. X11 is the Windows Manager. Well, not the Windows Manager. It's the display server that we're running on our Linux machine. So that's required to actually get things that can pop up as windows that we can see. Everybody got it?
Yeah. Just like that. If you type it in, you just work on it.
All right, you can check to see if it's installed by just typing Gnuplot now. You should see it pop up with a little, it's a little header printing. And you should see version 5, like I've got 5.0, patch level RC2. You should see 5 something. So there's a sandbox for today. So go into the sandbox directory. Start Gnuplot with the Gnuplot command in the sandbox directory.
How do you have a control C?
Exit.
Yeah. With brackets.
What's that?
You have to put a quotation. Like you have to put parentheses.
What do we need?
No, that's Python. This is Gnuplot.
Okay, because it wouldn't let me exit if I
Oh, there we go.
like several things were just like, no, you have to put these afterwards.
Let's make sure.
Which is today's.
Today's sandbox is the 22nd, which is right here. Of course, you have scripts that will automatically do this. Naming convention hasn't been changed yet. I'll do that on test day. Sandbox format has changed. Download the sandbox
You have to go there to get the PDF anyway.
for the homework, not for the sandbox.
Yes.
All right, so everybody got Gnuplot open in. Patrick, you all right? You just look so disappointed that you don't have a computer. Everybody got Gnuplot open in the sandbox directory?
Yes.
Okay. So you are now in the Gnuplot prompt. Gnuplot is now interpreting your inputs. The shell is not. Okay, so the stuff that Gnuplot supports will be interpreted. Stuff that was a shell feature no longer works unless Gnuplot has implemented it. The plot command will plot data. So if you just type plot space example.txt in quotes, you should see a plot pop up on your screen. And that is all that's required to get data plotted in Gnuplot. Dorn, are you having troubles over there? Like perhaps it's hard to hear.
Yes, I'm having trouble.
Is it working?
I'm not getting it installed.
Okay, what is it complaining about? Let's take a few minutes to make sure everybody is on the same page.
It's saying I have no confirmation.
Okay, so in that case,
Oh my, that's beautiful. Look at that.
New pot.
Look at that plot. What? The set command is used to configure your plot.
Oh, I can see why that was working. So such pretty little nuts.
Then.
It was really funny when Rusty Shepherd came back. The command is used to set the text, set the text.
Wanting that password, you check the group, the user account that you created, make sure that it's got that. So this. Okay, so now get into the sandbox directory. Okay, and open up Gnuplot. All right, so try to plot the file example.txt. Plot is a command, so it's going to be very similar to the shell in terms of, syntax or mechanics of getting stuff entered into Gnuplot, right? Commands take arguments. Arguments have to be separated from the command by spaces so that it can tell what the difference between the command and the space is. The plot command will take a file as an argument, but it has to be quoted. So you got to put quotes around the file name. And you should see something that pops up.
Yeah.
Okay. There's a lot of options that can be set, and those options are set with the set command. So set is the command name, and then you give set the name of the option that you want to set, and then you give it what you want to set the option to. So for example, the most common ones that you'd want immediately would be set X label. That's going to set the label on the X axis. So you do set X label, give it a string that you want it to set it to, and then it will set the X axis label. Set Y label, set title, right? Those are the basic ones that you'd have to have in order to get a graph that you could put into your report, for example, if you're taking a physics class. All right, so let me go into the sandbox directory. No kidding. All right, so Gnuplot opens up. Gnuplot is now interpreting commands. If you need to get out, just type exit. You don't have to do a Control-C. You type exit, it will close. All right, so here's the plot of example.txt. And I get a window that pops up, and I see some data points. Does everybody get this? Okay. A couple things to note. There's no label on the x-axis. There's no label on the y-axis. This is not the title. This is the window. It looks like there's actually 5 points here. There's a point down here in the bottom left corner, which is hard to see. Gnuplot auto scales for you. If you want that point to be more towards the center, or you want the left side of the plots to extend past that, then there are settings for that. There's one all the way up here at the top right corner. This one here is not a data point. It's actually just the key. So this is saying example.txt is plotted with purple crosses, right? If we plotted more than one thing, we'd have more entries in that, and it would tell us what the symbols were. I just want to quickly show what the format for these files is to get Gnuplots to plot. The format is very simple. It's a plain text file, which means that you could open up a file in Nano and create this file. Right? You could create a text file with data in it to plot in Gnuplot, which is really nice. So you don't have to have a spreadsheet to put your data into. You don't have to have a special program. Whatever your favorite text editor is, you can easily create a data file. This is also a very simple format to write like programs to create. So if I wanted to write a Python program that did some data analysis and then it was going to print some data to a file, this is absolutely trivial to create. So it's a very simple file format. There's 2 columns in this. First one you can barely see on this screen, right? So I've got each line is a data point. The first column is the X value. The second column is the Y value. And Gnuplot just reads this line by line and creates a data point for each one of these. They need to be separated by spaces or tabs, any number of spaces, any number of tabs. But they're not, I mean, it is possible to plot data that's in a comma separated format, but the easiest one to create is just a space separated format. So separate them by spaces and or tabs. Just do spaces, tabs are a pain. I'm gonna open up Gnuplot again. I'm gonna create this plot. All right, so there it is. All right, so let's set the x-axis label. So that's going to use the set command. I say set x label. I give it the string that I want it to put on the x-axis. So this is going to be x in centimeters. I'm putting the units for the x-axis in the label, which is good practice. Now, by default, nothing happens. Right? If I look at my Gnuplot window, nothing has happened. It's not until you replot the graph that it gets updated, which may seem sort of like a hassle initially, but sometimes when you're plotting things that are really big, it actually takes a considerable amount of time to generate the plot, and you don't want it trying to replot every time you're just changing some some configuration settings. So we can get this, I wonder if I can keep this on top, always on top. We can get the plot updated with the replot command. So now you see that I have a label on my x-axis down here.
You could just make your background, you could just make it fully transparent. That way you can only see it.
Oh yeah. I don't really like that though. I have a hard time seeing stuff. Another thing you'll already notice, this is a feature of the X11 Gnuplot terminal, is that my cursor here has got the position of the cursor on the graph is updated in the bottom left-hand corner. So you can always go over here and see roughly what the coordinates of all of these points are. Right, you can just drag your mouse through there and see that. Set Y label, so this will set the label on the Y-axis. This is going to be force in newtons. This is common with all Gnuplot commands. The shortest string required to make it unambiguous is accepted by Gnuplot. So there are no other commands that start with the letters REP, so REP will replot, right? And so I always use just rep for replot. And so now I see that I have a Y-axis label. And then if I need to set the title, it is the set title command. Well, it's the set command, title is an argument, what I want to set it to. I have to replot that in order to get it to take effect, and the title pops up right here at the top. And there you are, that's the basics. I mean, that'll get you 75% of what you ever need. Right? You need a title, some axes, labels, and you need your data on there. It's very easy to get stuff actually plotted quickly, right? So you can check to see if something looks right before you start tweaking or sort of fine-tuning what the graph is going to look like on paper. All right, so I'm going to exit.
So if you set them before you generate the graph, will it just still generate the same graph?
If you do the settings before you do the plot command,
Yeah, and then you just run the number.
then it'll still, all your settings will take effect. They get saved. And then if you do a replot, or if you just do another plot command, then they'll be on there. Yeah. Okay. You can't do a replot without having done a plot command first. Otherwise it'll complain.
How do you change the scale?
Like the X and Y axes. There's a option called X range and Y range, which we'll eventually do.
Okay. Oh man,
So the plot command is the thing that we're using, it's the central command for Gnuplot's functionality. There's a bunch of commands to change how the plot looks, but to actually plot data, it's the plot command. The plot command takes one or more arguments, and each one of those arguments can take one or more options. So this would be a command that would plot two files. So I would see two sets of data appear on the plot. One of them is the same one that we just did, and then there's another file called multicolumn.txt. These would then be plotted on the same graph. The plot command is the thing that's taking multiple arguments, and you separate the arguments with a comma. So this is saying plot this file and this file, and then if you give it another comma and the name of a file, it'll plot multiple files. You don't need to give the plot keyword every time, right? The plot command takes multiple arguments.
Will that plot it on separate graphs?
No, it'll plot it on the same graph. The options that can be given to the plot command, so this is an argument, and then you can give some options in the command line to the plot command that will change how the plots appear, right? The common ones would be title. So this is not set title something. This is setting the title of the plot. That will change the name that goes into the key. So the upper right-hand corner right now, the name that is used for your key, you can set with the title option. Line width you can use to change how big the points or the lines that you are drawing with are. The one that we're going to be using a lot is the using option. So you can actually set, if you've got more than two columns, you can tell Gnuplots to plot a file, but actually use columns 3 and 4 instead of 1 and 2, or use 1 and 3 or 1 and 4. So you can actually keep all of your data in a single file, and then you tell Gnuplot to pick out columns. So data files can contain multiple columns. By default, it's just going to print the second column versus the first column. So the first column is taken as X, which is the independent variable, and then the second column is taken as Y. You can change that with the using option. So this is the plot command. The multi-column.txt file has multiple columns in it, and then the using option takes an argument that specifies what columns I want to plot for the X and the Y values.
X would be first.
X is first, Y is second. Yep.
What if we want to plot the multi-column text, but we want to use for one of, like, we want to plot the same file twice on the same graph. So like using 1:2 and then using 1:3. Is that possible?
Yeah, yeah. You would just put a comma here and then plot the file with the columns that you want. And then the last option that I'll talk about is the with option. So you can tell Gnuplots to either plot just with points, plot with lines, or plot with points and lines. So basically draw points and connect them. All right, so let's see all of these things in action. Oh. Oh, I know what I did. Okay, give me 1 second again.
CD.
All right, so let me go back to my sandbox directory. Apparently I'm going to untar this as well.
Oh man.
There you go. All right.
See, show that you're making.
So here's the file that we've already plotted. Let me put this on top. The title option is different than setting the title with the set command. So the title option is going to change this piece right here. This is the title that is used with the plot command. What goes into that key? So if I do the plot command with title data, now I see that this string up here has been changed. If I don't want an entry at all, I just give it a blank string and it won't put in an entry for this plot. Gnuplot should have history as well. So you can use the up arrow to go back into your history to modify plot commands. The line width command is typically most useful if you're trying to create a figure and the dots on the figure that you're trying to print are too small. You can use the line width option to make them bigger so you can see that they're a little more pronounced now. There are a lot of shorthands for this. You know, you don't have to know the shorthands, but you do need to be aware that they exist in case you see somebody give you an example of a plot command. LW stands for line width. So in this case, it's not that line width is being abbreviated by the shortest string that makes it unambiguous. It's that LW is just an alias for that. So I'm going to make the line width 10, makes those crosses even bigger. You can change the line type, which Gnuplot has a set of line types that it has defined. And when you create multiple plots, the first plot gets line type 1, the second plot gets line type 2, the third plot gets line type 3. If you, for example, wanted to change the color of your dots here, then setting the line type is what you'd want to do. Or if you wanted to plot two things with the same line type, then you'd have to change the line type for the second item. So if I do line type 1, it looks just like it does without the line type option. If I do line type, what did I choose here? Line type 2, I should see the type that's used to create the points for the data has changed. And now they're nearly invisible blue X's. So that's the line type option. You have control over what type gets used for each one of the things that you put on your plot. And then LT is a shorthand for line type. Yes, Todd?
So we don't have control over the dot color and the shape of that dot.
Yes, but what you would end up doing is you'd have to define a line type and then you would specify that line type. So there are a set of line types that are defaults, and if those aren't good enough for you, then you would define your own line type. There are dozens of line types. So line type 3 is a blue asterisk, it looks like. All right, so let's look at this multi-column text file. So I'm just going to plot the multi-column text file. And it looks like I've got data that lies on top of a line, right? A bunch of data points sits on top of the line. It turns out that the multi-column data file contains multiple columns, but by default, it's just going to plot the first column and the second column. First column is X, second column is Y. So if I do the using command, and U is a shorthand for the using command, and I give the using command 1:2, it's just going to take first column for X, second column for Y. Generates the same plot. If I have, and let's just see what's in that. If I have data in a third column that I want to actually plot, then I give the using command with a third column. So let's look at what does the multi-column text file look like. So I've got multiple lines. There are 4 columns in the file. The first 2 columns are the ones that are used by default. If I wanted to use the first and the third column, I have to specify that with the using command. Yes, Joey? Did you get it figured out?
No.
You don't care anymore?
No. I'm trying something else first.
Okay. All right, so let's see what the third column has in it. All right, what is it?
That's a nice.
I went to plot multi-column.txt,
Mm-hmm.
and it's still using like my first plot. Like it still has like spring force and X in centimeters and force.
But it has different data.
No, it's got the same data. All I did is change like my legend thing to multi-column.txt.
That is interesting.
I did single quotes first, and I did it, and then after okay, maybe I'll try that quotes.
So what you had done is you had set, here you go, you set this X and this Y range. That makes auto scaling turn off. So now this is not over the same range, it was only showing the range of stuff before. So if you need to reset everything, the easiest way to do that is to close and open it back up. So what Joey's seeing is that he hasn't closed Gnuplot, so it still has the same y-axis label, the same x-axis label. He had set the x and the y range to be something that was not dynamic, and it won't auto zoom for you if you then plot a new file. So the third, let's see what's in the third column. The third column is a function that's not a line. It looks like it might be quadratic. And then you can see up here in the key, basically the file name and all of the options that I give it are going to appear in that key by default. That is almost never what you want to appear in a plot that's going to go into a report, right? So you're going to need to set the key title when you do plots like this.
So will we get bonus points from Jack if we say, well, we made this, I made my own new plot just for this lab?
No, he's probably gonna be like, wrong. I made one for you. Why didn't you just use mine?
That is something he would say. I don't know if Jack gives out bonus points, so.
He does not.
Yeah.
It doesn't mean he's having imaginary report.
He doesn't get on imaginary ones either.
Yeah, I mean, I'd give you imaginary points for it. So again, I've got 4 columns in this. That's why the using command works with 1:3. If you only have 2 columns, it's going to complain about no data to plot if you tried to do using 1:3. This is a really nice, useful one. You can plot the first column and the second column as X and Y, or you could flip them, right? So you basically can plot the inverse function by just saying, use the second column for X and use the first column for Y. So that should be a function that is essentially just the inverse of what you would get if you just plotted it without any arguments.
Yes.
As we'll see, it gets even more powerful than this. We can actually run every column through an arbitrary calculation and then use that result as a plot. Like let's say we wanted to plot the second column squared. We could tell it to square the number before it actually puts it onto the plot and have it plot directly from the same data file. Oh, I need to get that on top again.
Don't
Oops.
do that. I've done that.
Yeah, don't do that. That'll zoom in for you. So you can do, if you right click, you can zoom in. If you want to go back to auto zoom, then the keyboard shortcut is A. That goes to auto zoom. There's a keyboard shortcut R, which is for, I don't know what R stands for, but it marks your current cursor position. So if I can move my cursor here, I hit R, I get crosshairs at that position. What's really nice about this, oh, it must stand for ruler. So look at the bottom left-hand corner down here, right? This is my X and Y coordinate of my cursor. If I put my cursor somewhere and hit R, it now has an entry where the ruler is at. So this is the X and the Y coordinates of the ruler. This is the X and the Y coordinates of my cursor. And then this is the displacement between my cursor and the ruler. So I am almost 21 units to the left of my ruler and 60.7 units below my ruler. So you can actually measure distances pretty quickly in using Gnuplot. Like if you needed to measure, I don't know, let's say that you had an oscillation that you needed to measure the amplitude of from the peak to the bottom, you just mark the top, go down to the bottom, be able to pull off exactly what that amplitude is.
That's really, you can click it and it will set points with their data, with the little data.
Oh, look at that. So if you just middle mouse click it, you can put a whole bunch of them there.
Yeah.
Type A, they go away. If you use the mouse wheel, it scrolls up and down. So there are some nice interactive features.
Downright user friendly.
It's downright user. It's almost as if this program was built by somebody who actually needed to create plots a lot
Yeah.
and thought, how could I make this? How could I make this just easier to use as opposed to a giant hassle? So here's an example of setting two options at the same time. So I'm going to use the using option to specify the columns that I want, which are just 1 and 2. But the title up there contains the file name and then the options. And if I don't want that to appear in the key, then I can use the title command or the title option to set that. So now I've changed the name of that data set in the key. Here I'm going to plot a couple of functions on the same graph. So they're both in the same file. So I'm going to plot first and second column. I'm going to use the title option to set that key entry to data set 1. Then I'm going to plot the first and the third column. So this is what's really nice. The using command, the using option basically means that you can just put all of your data into a single file. You don't have to create a different file for every single function or data set that you want to plot. You can just put them all in the same file and then pick out the columns that you want to use. And so I've got the second plot is going to be out of the same file, and I've changed the entries here. So I've got data set 1, data set 2. You can see that they use different line types, right? One of them is purple crosses, and the other one is, oh, what is that, turquoise X's. There is a nice shorthand for this as well. If all of the data that you're wanting to plot is in the same file, you don't have to repeat the file name. You can actually just leave quotes, empty quotes, and it will use whatever the previous file name was. Let's say that I wanted to remove, like I wanted to plot this data and I wanted it to be in the key, but this second set of data, I didn't want it to have a key entry. All I got to do is set the key title to blank, right? So I give this title option blank string, and then it won't show up in the key. So it's not that it just sets the name to blank, it actually removes the point symbol there as well. And sometimes that's useful. Sometimes you have a line that you want to put on there without actually putting the thing that created that line in the key. Yeah, exactly. Like if you're gonna fit a line to your data, and then you wanted to plot that line on top of the data, and you didn't want that line to show up in the key. Here's the shortcut that I was telling you about. So I'm gonna plot stuff out of the multicolumn.txt file, and I'm gonna plot the first and second column, and then I'm gonna plot the first and third column. The second argument does not have to repeat that file name. I can just leave empty quotes, and then it will use the same file name from the previous argument. If I could tack on comma and the name of another file, comma, empty quotes, it always uses whatever the last file name that was given on that line is. So this gives me the same thing, same two data sets. Now here's the width option that I was telling you about. By default, data is going to be plotted with points. Functions, when we get to functions, will be plotted with lines. Sometimes you want your data to be plotted with lines. So all you got to do is give the width option. Lines will plot it with lines. And so this turns into a relatively smooth line. It will do some smoothing between the lines for you as well. Now, if your data is real coarse, that smoothing is not going to be real great. You're going to see some jagged edges on it. But if you zoom in, right, it draws a nice line on the graph. Sometimes you want to draw lines, but you also want the points that make up the data on there. And that line type, or I guess that option with the width command, is to use lines points.
And you're making a fancy little graph now.
Yeah, so I'm just adding more and more stuff. So I'm going to plot first and second column. Those are just going to be points. I'm going to plot first and third column. Those are going to be lines. And they're going to have, the key entry is going to be data set 2. And then I'm going to do the first and the fourth column as data set 3. And those are going to have lines and points. So it's going to have points connected by lines. They're going to be different colors. Right? So here is data set 3.
Really steep.
Very steep. This is a good way to make it look like you have a flat line, is to just plot something that's huge on the same graph. Then everything looks flat if it's not very big, right? So this is a good trick for putting, like a lab report. You want this data to look like it was a straight line that fits some equation. So you just put some giant function on there with it. Makes that bottom line look flat. 100%.
Yeah. If he looks over at your Unix and it's only like,
It's wild.
yeah.
Just that's how you get extra points.
Yeah.
All right, so we don't have time for this today. What I'm going to have you guys do the next time we get here is I've got some data files that are in the sandbox, and I'm going to have you go through and find the one that makes this plot. Same thing here, except this one may actually not be in the first and second column, so it might be in third or fourth column of the data file. And then I've got an example that I'll have you guys recreate. So we'll start this up on Friday.
That looks fun.
Isn't that a nice looking graph?
Yeah. Now you just need to put another edging graph on the bottom as well.
Yeah. So you want me to put the envelope?
Yeah, put it on both sides. Make a nice picture out of it. The damn harmonic oscillation.
I think it's a cosine.
Basically.
It starts at 0 though.